In the first section, we talked about the graphing. Now we're going to talk about specifically the equations. We're going to talk about the equations in section 2 and in section 3. And then we'll get back into the graphing. But first things first, factoring is a very rudimentary skill in both foundations and the pre-calculus strands. First thing about factoring that we need to recall from grade 10 is the greatest common factor. And you might notice that these examples are pretty much exactly the same as what we had done in grade 10 foundations, because they are so essential. You need to know how to do this factor. Of course, I do take it a little bit further in foundations 20 because there's a bit more that we need to know. So to factor things by the greatest common factor, we need to look and see, okay, what's common between 12 and 18? Well, the greatest number that's common between 12 and 18 is 6. So again, factoring is I'd say again, because we talked about in grade 10, factoring is like dividing. It's not actually dividing, because when we divide, and I'm saying that in quotation marks, we would actually get rid of this 6 factor. But when we factor it, we just take that 6 and put it in front. What we put inside our brackets is what this division is. Because 12x divided by 6 is 2x, and 18 divided by 6 is that 3. Of course, positive because it's addition. And this is factored by the greatest common factor. Our greatest common factor in the next one is just an x. So we'll be factoring an x out in front. Now, I don't typically write this divide by x every single time. It's a good thing to get started with, just to help you understand the very beginning. And then of course, we go much farther. So we take that x out, we'd be left with a 3x squared, a 5x, and a negative 1, because x divided by x is still 1. And our last one, our greatest common factor, looks like it's about 12. There is no x in this 60, so we can't actually factor 12 or can't factor an x out. But when we factor the 12 out, 36x to the power 4 divided by 12 is 3x to the power 4. And we continue on until we have the entire factored expression. So this is always the very first thing that we need to do. We always have to do this first. Sorry, I'm actually going to change that. You want a factor? You always have to consider your greatest common factor first, each and every single time. Now, after we've done our greatest common factor, we need to consider the following. Is the polynomial a trinomial or is it a binomial? Of course, tying back to grade 9, a trinomial is a 3-term polynomial and a binomial is a 2-term, just like a tricycle or a bicycle. 3 wheels or 2 wheels. So factoring a trinomial, which is the first option, is the one that typically takes more time, but can be done quickly depending on the type of trinomial. There are 2 types of trinomials that we really work with. We deal with simple trinomials and we deal with complex trinomials. Simple trinomials are obviously the easier one to factor. These trinomials have a very specific format. They're in the ax squared plus bx plus c, where a equals 1. So the number in front of the x squared is 1. So let's factor these simple trinomials. Well, there looks to be an issue here. We have a 2 in front of our x squared. But if we remember, factor the GCF first. You have to factor that greatest common factor first. There is a greatest common factor between these 3 terms. It's a 2. So we factor that 2 out. We would be left with an x squared, subtracting x, subtracting 6. After this, as I've stated, I don't give you the steps for factoring simple or complex trinomials. I expect that you have those skills committed to memory. Of course, we'll go through an example. Of course, we go through examples. I'm not just going to give you the answer. Our first step is always to take our a and multiply it by our c, the number in front of our x squared, and multiply it by the constant term. That is going to become our product. So 1 multiplied by -6 is -6. Second step is to identify the number in front of our x term. In this case, a -1. Our next step is to find two numbers that have the same product as our first step and the same sum as our second step. So our P and S, so product of -6 and the sum of -1, we always look at our factors of 6. So our factors of 6 are 1 and 6 because 1 times 6 is 6 and 2 times 3 is 6. Now obviously you should be able to tell 1 adding 6 in any kind of way, shape, or form, whether you have mixed signs or anything like that, will never give you a sum of -1. So those numbers are automatically out. But we could have these two numbers. If we have this as a -2 and a +3, well, of course, my -2 multiplied by +3 would give us -6, but -2 adding +3, because sum, would never give us -1. But if we change the signs to being a +2 and a -3, that would fit our two criteria. Because it's a simple trinomial, the only necessary step that we would need to do next is to have two sets of brackets, put an x in the first spot, put the +2 and the -3 in there. Of course, we factor that 2 out, we cannot forget that it's still there. B is already set up for full success because our a value, the number in front of our x squared, is already 1. So when we talked about our product and sum, our product of 1 multiplied by -16 being -16, our sum of -6. So again, we only really consider the factors of 16. 1 and 16, 2 and 8, 4 and 4. Of course, there's no way, shape, or form that 1 and 16 would ever add together give you -6. Same thing with the 4 and 4, which means we'd have to then look at the 2 times 8. The only way that we can get a sum of -6 is if our 8 was negative, which means that our 2 would have to be positive. So we make two sets of brackets. We put an x in the first spot, and then we'd have a +2 and a -8. Of course, the order doesn't really matter. You could have x subtract 8 and then x add 2, or you could have it just as written here. Last simple factoring. Again, there's a number in front of that squared term. It doesn't have to necessarily be x because we're going to work with other variables as well. Or t is another fun one that I like using. Of course, I say fun because math is fun. But our x squared, our h squared in this case, our x or our h in this one, still fits. Our greatest common factor, which again is the first thing we do, is to factor out that -5. Subtract 12. So we look to our product and sum. Product of 1 multiplied by -12. Our sum, 4. You don't necessarily have to write down every single one of our factors of the product term each and every single time. It is just something that works. Because you may think that you have an answer, but then it doesn't actually work. 1 and 12 will never give you 4. 3 and 4 will never give you 4. The only way we can get a product of -12 and a sum of +4 is to have a -2 and a +6. we set up our brackets. In this one, it's h. Put a -2 and a +6. Don't forget the -5 out in front. And that's our simple factoring. Our next one we're going to talk about is our complex factoring. The only difference between simple and complex factoring is that, yes, it's still in the same standard form, but the a value is not equal to 1. For example, 2x squared subtract 3x add 5, and there is no greatest common factor that we can further take out. So we just have to follow some steps. I do like using these steps. But by the time that we're in grade 11, we will have practiced this method well enough to have it memorized, have it written down, so we can do it. You'll notice that the first 3 steps are the same things that we use for simple factoring. The reason that it's complex is because we're going to have to do more steps. So our first one, we're going to factor these complex trinomials. So to factor these complex trinomials, first, any GCF? Nope. So we're all good. Find the product of the leading coefficient, in this case, 2, which is our a value, and our constant term, which is a c. 2 multiplied by 4 is 8. Second step, identify the term in front of the x. In this case, 9. It's going to become our s. Find 2 numbers that have the same product and sum as our chart. Again, look at our product. So our factors of 8 will be 1 and 8, and 2 and 4. 2 and 4 would never give us 9, but a +1 and a +8 do multiply to give us +8, and they also add together to give us 9. They have a product of 8 and a sum of 9. So here's where it obviously differs from simple factoring. We have to break our x term into these 2 numbers from here. Now, if you'll remember, these steps still work for simple factoring, but in simple factoring, we don't have to do these 3 steps because it would just take us more time. For complex factoring, we do. Now, of course, this method is known as decomposition. And it's actually known as decomposition specifically because of this step 4. Because we are breaking the 9x down into 2 terms, we are decomposing the 9 into a +1x and a +8x. All right, let's keep on going. Just bring down the other terms. Now we're going to split our 4 terms in half. Done. That's probably my favorite step because it's extremely simple. Now we find the GCF and factor from the first 2 terms and then the last 2 terms, which means we're looking at these first 2 terms and finding a GCF. In this case, it's x. When we factor that x out, we would be left with a 2x add 1. When we look at the next 2 terms, the last 2 terms, there is a +4 that's common, leaving us with a 2x add 1. The thing that you always have to do is make sure that this factor and this factor are always the same. They have to be the same. If they are not the same, you have not done your factoring correctly. Because our last step is find this common factor and factor it. Because we can factor 2x add 1 out of each of these 2 terms. Well, if we factor 2x plus 1 out of this first term, we'd be left with an x. If we factor 2x add 1 out of this term, we'd be left with a +4. And now we have everything factored. You may ask the question again, does it matter which one you put first? Nope. Either of these ones can be switched. We could have written our 8x, then our 1x, and it would still work out perfectly. All right, next step. Or sorry, next question. Well, here, first step to factoring is always our greatest common factor. We have a y common in each and every single one of these. So we have to factor that out. If you don't factor it out, you're hurting yourself. So our product of our leading coefficient and our constant term, our a and c, will be a negative 60. Sum of negative 17. So for larger numbers, it obviously becomes a little bit harder. But I also have this specific question for a reason. Factors of 1 and 60 or sorry, factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. So if we look at these numbers immediately, to get a sum of negative 17, well, those two would never work. Same with these ones. But 3 and 20 could. 4 and 15 would never give us a 17 as anything. But the 5 and 12 could. 6 and 10 do not. So this is where you have to have an understanding of what our factors are. That has to fit these two strict criteria. It has to have a product of negative 60 and the sum of negative 17. If by chance, so to get a sum of negative 17, both of these would have to be negative. But if both of these are negative, you can never get a product of negative 60, which means these are not the numbers we're working with. You will always only have one set of numbers that works. You will never have two sets of numbers that would work. Of course, the only way they would get a product of negative 60 and a sum of negative 17 would have a negative 20 and a positive 3. Now I'm just going to kind of ignore our y just for a moment. While we break down our negative 17x into a positive 3x and a negative 20x. Sorry, I'll just get rid of this parenthesis for a second. Our next step, split her down the middle. Greatest common factor in the first two terms is an x. We would be left with a 4x, add 3. Greatest common factor between negative 20 and negative 15. I'll review this from last year. If we leave it as a positive 4. So if you're writing this along with us, don't copy this quite yet. If we factor a negative or positive 4 out of here, we'd be left with, sorry, not negative, positive 4, 5. There's definitely not a 4 in 15. Factor of 5 out, we'd be left with a negative 4x, subtract 3. This factor has to be the exact same as that factor. The only way for us to make that, and this is the things that you can be writing, the only way that it would work is to have as a negative 5 and a positive 3. Sorry, just changing those signs. Of course, this would be positive 4. Now that these are the same, now we are actually set to go. We can factor 4x add 3 out of each of those terms. If we factor the 4x add 3 out of the first one, we're left with an x. Factoring the 4x add 3 out of the next one, we'd be left with a negative 5. And there is our complex trinomial factored, except can't forget about our y. And there we go. We're good to go now. Now, the last real factoring that we're doing as a review is a difference of squares. These have a very specific form, which is a square subtracting a square. 81m squared and 16 are both perfect squares. In order to factor perfect squares, we look at what the square roots of each of those two terms are. Write down two sets of brackets. We write down the square root of the first term, so the square root of 81m squared, what number or what polynomial multiplied by itself gives us 81m squared? Well, that would be 9m. We'd have to put that in the first spot. Sorry, I'm just going to change my colors. The square root of 16, now we're not doing the negative 16, we're just doing the 16, is a 4 and 4. Now the entire idea behind a difference of squares is that when it's factored, one has to be positive and one has to be negative. Because if we distribute out, just like we had done last year, our middle two terms would actually cancel off, and we'd be left with the 81m squared subtracting 16. Our next example, well, neither of these are perfect squares. Hence, our first step to factoring, our greatest common factor, each and every single time. Cannot forget that there is a greatest common factor. So for this one, we have 7y. 7y squared would be our greatest common factor. We factor that out, we'd be left with a 9x squared subtracting 4. So our next bit of factoring, take the square root of the 9x squared. Sorry, write down our two sets of brackets. Square root of the 9x squared will be a 3x. Take the square root of 4, which will be 2. Make one addition, make one subtraction. Don't forget about our 7y squared. And that's all of our real review that we need to know for Foundations 20. Of course, Foundations 20 does go into the actual applications of this quadratic factoring, which means we need to know one more thing, which is really just our simple, our complex, our difference of squares, and our greatest common factoring, just kind of all together. But at the same time, they're separate because you just have to follow which format we need to do. Solving a quadratic function takes very little extra work. Oh. Yeah. Sorry, I was talking about more things than we needed, but we're still good. The big reason that we need to remember or learn how, review how to do our factoring is because we have to also solve. This is one of our very key aspects that we have done in Pre-Calc 20, and those of you that are going on to Pre-Calc 30 will also be doing it. Of course, we do the same thing in Foundations 20 and in Foundations 30. In order to solve a function, it means finding the roots, zeros, x-intercepts, and of course, the solutions. In other words, what it's really asking us to do is find out where a graph crosses the x-axis. In order to find out where a function crosses the x-axis, we have to look at the y value. And as we remembered from our section 1, if it's crossing the x-axis, it means our y equals 0. If our y equals 0, what we do is we need to set our factors. Set the factors to equal 0, and then solve for x. So let's go into some examples here. F of x equals 2x squared at 14x, that's a typo. Add 12. I'll make sure I get that fixed up. Well, the first thing that we need to do is set our y equal to 0. Of course, as we learned in Foundations 10, f of x is y. So we just set it equal to 0. So we have 2x squared, add 14x, add 12, equal to 0. Then what we're going to do is we're going to factor. So our first step to factoring, of course, is our GCF. So we factor our 2 out. Being left with x squared, add 7x, add 6. This is a simple factoring now, which means we can simply go into our product sum. I'll leave it over here. Product of 1 times 6, sum of 7. The two numbers that actually work out, of course, I don't have to go into 1, 6, 2, 3. I know that it's already going to be 1 and 6, and they're both going to be positive, which means I'm going to have an x add 1, and an x add 6, 2 out in front, equal to 0. The extension from our Foundations 10 into our Foundations 20 is we have to set our factors, which are these 3 factors, to equal 0. The first one is a little redundant because there's no variable. We know that 2 never equals 0. Sorry, I'll do that one properly. We know that 2 does not equal 0. So we don't really have to consider coefficients that do not have variables. If it does have a variable, we do have to consider it. Next one is x add 1. We set it equal to 0. Well, where does x add 1 equal 0? Solve for x by subtracting 1. X equals -1. And our last factor, x add 6, equals 0. Again, we set our factors to equal 0. We solve for x. This one, we subtract the 6, and x equals -6. Now to help verify, I like showing that, yeah, this actually works. Because if x equals -1, we're going to make sure that this equation actually works out. So we plug -1 for our x's. And make sure it fully works out. -1 squared is 1, multiplied by 2 is 2. Positive 14 multiplied by -1 is -14. Add the 12. Yeah, 0 equals 0. Because 2 subtract 14, add 12 is 0. If I use the other factor of x equals -6, I do the exact same thing. 2 multiplied by -6 squared. Add 14 by -6. Add 12. See, -6 squared is 36. 2 times 36 is 72. Sorry. 14 by 6. Sorry, by -6. Should be a -84. Add 12. 72 subtracting 84 is -12. Add 12 is 0. So both of these work, which means -1 and -6 are the answers. They are the roots. They are the solutions. They are the zeros. They are the x-intercepts. If we do the same type of work to this one, set our y equals 0. Now you may not notice it, but there is actually something to factor out. Our a value is not 1, it's -1, which means we need to actually factor a -1 out first. It's one of the skills that those of you that have taken Pre-Calc 20 will be familiar with. course, a lot of things that we've done in pre-calc 20 will also have to apply to foundations 20. That is definitely not right. Sorry. I factor a -1 out. I should make sure I factor it out properly. I factor a -1 out of a positive 6, it should be -6, and I factor that -1 out of 10, it should be a -10. Now I can do my product and sum properly. So product of -10, sum of -6. Two numbers that actually work out. Ah, that's right. I changed this. So I'll make sure that on your official version should be reading as -8 first. Sorry about that. So we factor that -1 out. We'd be left with a positive 8. Now we're good to go. Just have to change my product. 1 multiplied by 8 is 8. And the two numbers that would have a product of 8 and a sum of -6 will be a -2 and a -4. Now we're good to go. Have our factor of -1. Make our two sets of brackets. X subtract 2, X subtract 4. Of course, just like we had done over here, -1 for sure does not equal 0. Well, X subtract 2 could potentially equal 0, as we could add 2 to both sides, and X would equal 2. X subtract 4 equals 0. By adding 4. X equals 4. And those will be our two answers. But we're going to verify. So our verification of X equals 2 and our verification of X equals 4. I'm going to plug the 2 into the original equation. And I'll make sure that's fully fixed up in your version. But we want to make sure it's equal to 0. So a negative of 2 squared, adding 6 multiplied by the 2, subtracting the 8. So 2 squared is 4, so we'd have -4. 6 times by 2 is 12, subtract the 8. And -4 add 12, subtract 8, absolutely is 0. That actually looked like a 0. Yeah, that one's definitely good. Okay, that's for your check mark. We do the same thing on this one. Plug our 4 in. Four squared is 16, so -16. Add 24, subtract 8. Yep, that for sure comes out as 0. We are all good. Our two answers are 2 and 4. Let's go into the next one. Now you'll notice that it's already equals 0. So we're actually kind of set. First thing that we need to do, though, is look at our greatest common factor. By divisibility rules, we can factor 3 out of each of these. Factor 3 out of 75x squared, we would have 25x squared. Factor 3 out of 192, we get 64. There's only 2 terms. We can't do a product and sum. Well, technically we could, but there's a shortcut, and that's to use our difference of squares. That 3 would still be on front, but we do have to set up 2 sets of brackets. The square root of 25x squared is a 5x. So that goes into that first spot. The square root of 64 is 8. All we'd have to do, make one positive and one negative, and it absolutely equals 0. Our next step, set our factors. 3 equals 0, well, we know that that one doesn't work. If you get in the habit of it, great, but you technically do not need things that do not have a variable. If we were able to factor a 3x out, 3x could equal 0. So you have to be careful. If it's just a number, a coefficient, you're good. You would not technically need to put that and set it equal to 0. Alrighty. Set each of our other factors equal to 0. In order to solve, I'd have to subtract 8 from both sides here. So I'd have 5x equal to negative 8. Divide by the 5. And x would equal a positive 8 over 5. Do the same work over here. The only difference, add the 8. Oh, sorry, I forgot the negative on this one. That's why you have to make sure you do take things nice and carefully, nice and slow. That way you can catch errors. Still divide by 5. This one is the positive 8 over 5. So to check things out, one for negative 8 over 5 and one for positive 8 over 5. So that 8 over 5 Alrighty. So 8 over 5 squared means that we'd be squaring the numerator and squaring the denominator. So we would have 64 over 25. Well, we can reduce the 75 and the 25 to be 3. 3 multiplied by 64 is 192. And 192 subtract 192 is 0. So that's a great factor. The next one is almost the same identical work. Sorry, yeah, that should have been the negative, but it's still positive. We put that a over 5 in, and we still come out as at 64 over 25. And we know that that will reduce down to be 192. And absolutely 0 equals 0. So we're good. To write this in a condensed version, we would write 8 over 5, and we use this symbol, plus or minus. It is not wrong to write it as negative 8 over 5, comma, positive 8 over 5. This is just the condensed version. Next example. Well, this one's a little bit tricky, but not really. We're still finding out our roots or zeros or x-intercepts, anywhere it crosses, but it has to have y equal to 0. In each and every single one of these other examples, we see that one side is equal to 0. Doesn't matter whether it's the left or whether it's the right. We are going to have to do some factoring here. But in order to factor, we need to have one side equal to 0. This one, we're going to have to move our 49 over. And I can tell I already have another typo. That should be a 28x. Sorry. So I'm going to add my 49. So I got 4x squared, adding 28x, adding 49. There's no greatest common factor, so we're going to have to do some complex factoring. Our product and sum, 4 by 49, it's 196. Sum, 28. Of course, in grade 10, we had done questions that were as complex as this one. It's not actually as bad as you think. Our two numbers I know by practice, and the fact that I know my perfect squares, the two factors are 14 and 14. Absolutely, if you need to go through every single one of our product pairs or factor pairs to find out what two numbers would have a product of 196, go for it. But I know that 14 and 14 works. You can start with 1 and 196, 2 and 98, and keep on going on like that. But I got my numbers. So a positive 14x and a positive 14x. This is a complex factoring, so split her in half. Common between 4x squared and 14x squared will be a 2x. We'd be left with a 2x adding 7. Between these two would be a positive 7. And now to 2x add 7. So our two factors, by factoring once again, would be a 2x. Oh, forgot about my 0. Would be 2x add 7 and 2x add 7. Now this is a special case because this could also be written as 2x add 7 squared, since they are the exact same factor. And it is just 2x add 7 multiplied by itself. That's why we can write it as squared. If we want to find out our zeros, we just have to set our 2x add 7 to equal 0. We do not have to do it twice because they're the exact same thing. By subtracting the 7, we'd have 2x equal to negative 7. And divide by the 2. So x would equal negative 7 over 2. Not sure if you see, but it looks like my computer's being nice and slow as my characters are being written. But we're just about done this section, so we're good to go. So we plug our negative 7 over 2. Technically, we could put it into the first one, but I'll put it into the second one because we can. I like having things equal to 0. So 4, put the negative 7 over 2 squared, and the 28 multiplied by the negative 7 over 2. Add the 49, and we can keep on rocking and rolling. Negative 7 over 2 squared will be 49 over 4. Actually, sorry. I can do this multiplication really nicely. Because 28 and 2 reduce gives me 14. And a 14 multiplied by 7 would be 98, but it's positive by a negative. So negative. At the same time, 4 and 4 completely reduce. I'd have 49, subtracting 98, so adding 49. And I know for a fact that that sum and difference equals 0. So our factor, our 0, our x-intercept, is negative 7 over 2. Alrighty, one more factoring. This is a little bit different than what we've done before. Because there's a number in front of our x squared that we've never really had to factor. But this is just really nice and special. We still have it equal to 0. The only difference is we will treat this as our greatest common factor. So we are going to factor that negative 0.625 out of each and every single one of these terms. We factor it out of our first term, we'd just be left with an x squared. But 5, factoring out a negative 0.625, will be a negative 8x. And a 7.5, factoring out that 0.625, would be a positive 12. Now we are set up for our simple factoring because our number in front of our x squared is 1. A product of 12, a sum of negative 8. The two numbers that would work, negative 6 and negative 2. So we'd have x subtract 6 and x subtract 2. So our factors equal to 0. Yes, I know that I've done this one slightly differently than the other ones. I've done one thing at a time. But we've also done enough practice that you can see that working with them simultaneously really doesn't change our numbers. Doesn't really change anything too much. The only thing we have to do is check to make sure that 6 and 2 work. So negative 0.625. We plug the 6 in. 5 times 6, subtract the 7.5. Make that a 5. So 6 squared is 36. 36 multiplied by the negative 0.625. Will be 22.5. 5 multiplied by 6. Sorry, that should be a negative. 5 by 6 is 30. If you subtract that 7.5, 0 equals 0. So that one's good. So I can already start off with my solution set. If I plug the 2 in, make that a 2. Adding the 5 times by the 2, subtracting the 7.5. Alrighty, 2 squared is 4. 4 multiplied by the negative 6.25. We get negative 2.5. 5 times 2 is 10. Subtract the 7.5. Yep. That also works out as 0. So we are all good with both of those answers. 2 and 6 are good answers. And there's our review of factoring and our next step into actually solving. Finding the roots, finding the zeros, finding the x-intercepts. We'll talk about exactly what these mean more in our section 4. All right, go have fun.